It's the 2026 calendar. I actually looked closer at it. We got it from a Chinese restaurant in Reading when I was visiting my dad. He didn't want it, so he gave it to me. Free calendar. Hey, I'm not going to complain. We like free things. All right. So, as mentioned, we are focusing on estimating unknown quantities about a population. And we're going to kind of alternate. We're going to start with Unit 6. We're going to look at categorical data, specifically proportions, which look at a percentage of the population that has a certain characteristic, which is why it's categorical. And then in Unit 7, we'll come back to quantitative data. We'll look at means or averages. And then we'll go back and look at categorical data in two-way tables. And then we'll go back to numeric data with paired data, x, y values. So back, forth, back, forth. But we're doing the same two things in every unit. How do I estimate unknown values? How do I test claims that somebody else has made about a population? And today we're going to start with the basics about doing confidence intervals or interval estimates. Okay, so when I saw you in December, we learned about point estimates. I'm hoping that sounds familiar. Yes. Point estimate is a statistic, a sample value. We did examples of sample means. We looked at the height of students in our classroom. Yeah. And point estimates are single values pulled from sample data that are used to estimate an unknown population, I can spell, parameter. Sample statistics, population parameters. So we are using a sample statistic to estimate an unknown population parameter. That is a point estimate. We also learned last semester that those single value estimates are very rarely spot on. It's very rare when you throw a dart, we're going to hit the dead center of the dartboard. So what we want to do as statisticians is use an interval estimate instead. That is the most common form of estimate. The reason we did point estimates first is those point estimates are going to become the center of our interval. We're going to use those point estimates, and then we're going to go out in either direction to form a range. So the interval estimate we're using is called a confidence interval, and it gives a set of plausible values. For an unknown parameter based on sample data. And we need to get nitpicky about our vocab. What does the word plausible mean? I say something is plausible, what am I saying? Reasonable, yeah, or believable. Good, reasonable or believable. Yeah. Saying that the average height of students at Rancho San Juan is 5'7", that's a plausible value based on what we see in the hallway. Saying that the average height of students at Rancho San Juan is 3'2" is not a plausible value, because you walk out in the hallway and you can see that almost everybody in the hallway is taller than 3'2". So plausible means believable based on what we know about our population. Different from probable. Probable has to do with likely or unlikely to happen. Possible means the range of all values that can happen. We're talking about human height. What's the shortest a human can be? We're talking about adults. Yeah, probably the shortest person who has dwarfism, about 1 or 2 feet. Yeah, the tallest is about what, 8 or 9 feet ever recorded. right? So possible is different from plausible, right? Our mean height could be anything between that min and max, but it's not likely to be. And it's definitely not believable that I'd have a mean that's that low or that high. So plausible is very different than probable or possible. We need to be specific with our words. So today we're going to focus on interpreting, and we're going to learn 2 sentence frames today. We like sentence frames because you're going to use them for every unit for second semester. We're going to see the same sentence frames over and over again. That's why we're starting with sentence frames before we get into the math. So the first thing you need to know is that all confidence intervals for every unit we're going to do this semester have the same structure. They start with our point estimate, our sample statistic, and then based on how certain I want to be that my interval contains the actual population value, I'm going to build a margin of error out in either direction. Do I want to estimate my answer within 1%, 2%, 5%, 8%? How certain do I want to be? All of them will look like this. The sample statistic is going to change depending on the parameter that I'm estimating. In this case, in Unit 6, I'm estimating a population proportion. So my sample statistic is going to be the sample proportion, p hat. When I'm estimating sample or population means mu, my sample statistic is going to be the sample mean x bar. So these will match whatever the population value I'm estimating is. And that will change depending on the sampling distribution we're using. I'm hoping that word sounds familiar. So when we build these, our sample stat forms the center of the interval. And the margin of error is determined by how certain we want to be that our interval captures our value. Can I write today? No. And you'll notice there's 2 blanks there because you're going to see 2 different ways that the AP test will phrase that. So the margin of error is determined by how certain we want to be that the resulting interval captures the true parameter, which is another way that the AP test is going to say population parameter. Those 2 words are now interchangeable in terms of our sentences and our explanations. True parameter and population parameter mean the same thing. True is telling you it's the population value. It's the actual value looking at everybody in the population. Okay. Our level of certainty is measured with something called a confidence level. Because statisticians are very creative with their naming. So the confidence level is how certain I want to be that my interval is going to capture the actual value I'm trying to estimate. The more certain I want to be that my interval captures the actual population value, the wider that interval is going to become. And we can think of this in terms of dartboards. If I'm throwing darts at a board, is it easier to hit a big board or a teeny board? Big board, right? There's more area to hit. So even if my aim is bad, I'm more likely to hit it. Yeah. Same thing with confidence intervals. So I want to be more certain that my population value is going to be somewhere in that interval. I want to make my interval wider. So the more confident I become, the wider my interval becomes. So the bigger the confidence level, the wider the interval. The smaller the confidence level, the smaller the interval. Yeah? Easy to remember. Okay. Deep breath. Sentence frames. You are going to notice that the AP board is going to do two different things when they talk about confidence intervals and estimations. Sometimes they're going to ask you to interpret the confidence interval itself. This is that usual summary sentence we write at the end of a word problem. Interpret the numbers you just calculated. And for all confidence intervals, we are using the same sentence frame. That works for everything in semester 2. If you're asked to interpret a confidence interval, that's the sentence we use. And the sentence is, we are, try that again, C% confident that the interval from blank to blank, whatever those boundary values are, captures the population parameter. And you may notice that there's extra room on that line, because you are not just going to write that we are 95% confident that the interval from 5 to 10 captures the true population proportion. You need to write what that population parameter is in context. I am 95% confident that the interval from 65 to 80 captures the true proportion of Rancho San Juan students that slept past noon at least once during their Christmas break. Yeah. These blanks are the boundary values that form our confidence interval, the lower bound, the upper bound. We take our center, we subtract, that gives us the lower. We take our center, we add, that gives us the upper. And it's that lower and upper that go here and here. These come from the do step in our state plan do conclude. So this is the math that we're going to talk about when I see you on Friday. Where do those numbers come from? And that's going to change depending on the parameter that we're estimating. But this sentence frame is going to be the same regardless. C% my confidence level. You slap it in there from the word problem. Plug the numbers in that you get from your math. Copy the context from the problem. What is it that you're estimating in words? Yeah? Good. We're going to practice. Just the interpretation, because that's half the points on your FRQ is, can I write that sentence? All right, who wants to read example 1 for us? Thank you, Roy.
Example 1. The National Health and Nutrition Examination Survey is an ongoing research program conducted by the National Center for Health Statistics. Based on a random sample of 500 U.S. residents aged 8 or older, a 95% confidence interval for the mean systolic blood pressure, the upper number on the blood pressure measurement is 119.6 to 123.6 millimeters of mercury. Interpret this confidence interval.
Thank you. Very good. So 2 things when we read the word problem. What information did they give us? What are they asking us to do? Let's start with the what are they asking us to do? Who can tell me, what did they ask us to do? Interpret. Yeah. Right. Very clear. Last sentence. Interpret the confidence interval. Don't calculate anything. Interpret. I know interpret means write a sentence. That sentence should include words from the original problem. Context from the problem. Next thing I'm going to do is pick through the problem for information that I need. And I know that when I'm interpreting a confidence interval, I need the confidence level I need the lower and upper bound of the interval. I need the thing I'm estimating in words. So who can tell me what our confidence level is? 95%. Very good, because they said 95% confidence interval. So my C percent is 95. Perfect. Next piece. I need the lower and upper bound for my interval. Raise your hand who can tell me what those values are. Yeah. Very good. Very good. So 119.6 mmHg to 123.6 mmHg. And the last part, which is what population parameter am I estimating? So take a minute, check with your neighbors, give you about 30 seconds, and then I'm going to need a volunteer to tell me. Of course they give us somebody who's not here today. All right, Stacia, what are we estimating with this problem? Interval for the mean systolic blood pressure. There we go. Good. We're estimating the mean systolic blood pressure. So this is the confidence interval for a mean or an average. Good. And now that I have those pieces, all I have to do is plug them into my sentence. And I have it right there, right? I'm just going to copy and fill in the blanks as I go. So my sentence is, we are, and then I'm going to grab my confidence level, 95%. And then I'm going to keep copying the sentence frame. Confident that the interval from, and then I encounter that pair of blanks, and that's what I wrote in green. That's that lower bound and upper bound. So 119.6 to 123.6. That's my pair of blanks. And then I keep copying the sentence frame. Captures the, and then population parameter in context. And that's what we highlighted in yellow. So population, mean systolic blood pressure. That same sentence over and over. Every time you do a confidence interval, that should be in the very last step. That is your conclusion. You are going to be sick of this sentence frame. It should be stuck in your brain by the time we hit April. That's the goal. We're doing this lots and lots. Good. Questions on where the information that we plugged into the sentence frame came from? The prompt. Very good. Okay. We'll do another example. I am going to pop on about 3 minutes on the clock. I want you guys to write your sentence. I'm going to call on a volunteer to read their sentence to us. It's good for you guys. I've missed that noise. 3 weeks of no clay slamming. Yeah. Right, what?
Should I just write like the whole thing? Or can I just say like the healthcare programs? Like, are you in favor of substantially increasing federal spending on increasing?
So, it says confidence interval for the proportion of U.S. adults who would say yes to this question is sufficient, or the proportion of U.S. adults who would say yes to question about their views on healthcare or federal spending. Yeah. Some context that we know it's a proportion of the population, U.S. population, that said yes. Okay, Larissa was our lucky name. Larissa, how do we start our sentence? I got that far. Favor increasing federal spending on healthcare. Is that what I heard? Okay. Can I get a thumbs up from the individuals in the class who have a sentence very similar to Larissa's? I'm getting thumbs up popping up around tables around the room. Very good. Do we all agree with the 95%? Good. They told us 95% confident interval. Do we all agree with the lower and upper bounds? Good. Do we agree with the proportion as described in context of the problem? I see some nodding, and I'm guessing not all of you use that exact wording. So the important pieces that the AP board is going to be looking for, either the word true or population, indicate that it's for the whole US, indicate that it's a proportion, and then indicate what is a proportion or percentage of. So US adults who, and then you could have phrased after the who a lot of ways. Who said yes to the question, right? Because that's what they said down here. That would have been fine. Who said yes to increasing healthcare spending? Who said yes to blah, 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 right? There's lots of ways to phrase that context because there were two different places where they described what they were measuring the proportion of, but it needed to have true or population, proportion of, and then some wording from the question. Good. Very good. Questions on how that sentence frame works? No. Good. All right. So, knowing that interval also allows us to make conclusions or justify statistical claims. Because if I know what a range of plausible values is, I can tell whether a value somebody else gave me is plausible or not. So our next example, we're going to do that. And you'll notice we're back to that systolic blood pressure example. It says in example 1, you learn the 95% confidence interval for the mean systolic blood pressure of all US residents 8 or older is 119.6 to 123.6 millimeters of mercury. According to the CDC, normal systolic blood pressure is less than or equal to 120 millimeters of mercury. Based on this interval, is there convincing evidence that the mean systolic blood pressure of all US residents aged 8 and older is greater than 120 millimeters of mercury? Explain. So, they've given us two pieces of information. They've given us an interval. Those are my plausible values based on sample data from the population. I expect the mean for everybody 8 and older in the US is somewhere in that number range. And then they gave us a value to compare against, which is 120 millimeters of mercury or bigger. Millimeters. Based on that interval, can I conclude that the mean for the whole US is greater than 120? The question is, how do I decide? So if I look at that interval, 119.6, 123.6, and I look at that on a number line, where does 120 fall? It's on the left, but is it less than 119 or greater than 119? Greater. So there are some plausible values that are less than 120. Not a whole lot. 119.9, 119.8, 119.7, 119.6. But it is plausible that the mean for the US is less than 120. Can I, as a statistician, conclusively state that the mean for the US is bigger than 120? No, because there are plausible values that are less than 120. If my entire interval was bigger than 120, if it was like 121.6 to 128.6, then I could say, yes, the mean for the US has to be bigger than 120 because all of my plausible values are bigger than 120. But if some of my plausible values are less, I cannot conclusively state that the mean has to be bigger than 120. It could be less than, it could be equal to, because 120 is inside that range somewhere. So for confidence intervals, when I'm using them to make claims, I'm asking myself, is the claimed value inside my range of plausible values or outside my range of plausible values? If it's inside that list of plausible values, I can't really draw a conclusion because it's plausible. I can't discount it. But if that value is outside, then I can make a conclusive statement because the value they gave me isn't plausible based on that sample data. The upside is you're not going to be asked to do this a whole lot because what we're doing for the second half of Unit 6 is how to perform a test to determine whether something is plausible or not. That's the second type of inference. Okay. I promised 2 sentence frames today. Second sentence frame. We know how to confidence. We know how to interpret the confidence interval. I got a range of values. How do I interpret it? The other thing you will be asked to interpret is the confidence level itself. And remember that confidence level is how certain I want to be that my interval captures the population value. And there is a sentence frame for that because they are looking for a very specific interpretation of that value. And it's going to be the same interpretation for every confidence interval we build all of semester 2. So our confidence level, we've been using 95% for all our examples, gives the approximate percentage of confidence intervals that will capture the population parameter in repeated random samplings of the same size. I'm going to draw a picture before we practice interpreting. So what that is telling me is, let's say, for example, I happen to know for a fact that the average systolic blood pressure is 120. That's my actual population mean. If I am constructing a 95% confidence interval, what that means is I expect that 95% of the intervals that I construct will contain that value. So we had one here, 119 to 126. Yeah, we'll have some here. Some of them will not capture that value. But if I am 95% certain, I am expecting that 95% have that red line passing through the middle somewhere. That's what we're saying when we're saying we're 95% confident. It means that 95% of the samples that I can collect from a population are going to produce an interval that captures the actual value. That is the interpretation that they are expecting you to give. It's not how we typically refer to C%. I'm 95% confident my interval captures a value, but that's not what they want to hear when they're asking you to interpret your confidence level. The confidence level itself is separate from the interval. It is this idea here. If I'm 90% confident, 90% of the intervals I construct, 9 out of every 10, are going to capture the population value. Yeah. That is a hard idea to digest. So until you understand it up here and you practice with it, there is a sentence frame. This is your friend for your homework. Please use it. If the word problem asks you to interpret the confidence level, you are going to state, if we were to select many random samples of the same size from the same population and construct a C% confidence interval using each sample, we expect about C% of the intervals would capture the population value. Notice the only number up there is the confidence level, C%. No interval, no specific sample. I'm just worried about what that confidence level means. Yeah? Nod your head yes. You will notice population parameter in context. It is important that you read directions carefully. Some problems on the FRQ are going to ask you to interpret the confidence interval only. Some are going to ask you to interpret the confidence level only. Some are going to ask that you do both. When in doubt, do both. It is better to have extra correct information than not enough correct information. So when in doubt, do both. Okay, last example. We're going to interpret a confidence level. It says examples 1 and 3, we learned the 95% confidence interval for the mean systolic blood pressure was 119.6 to 123.6 millimeters of mercury. Interpret the confidence interval. Not too bad. We start copying. If we were to select, and yes, this is tedious, welcome to statistics, many random samples, the next chunk of that statement is important. Of the same size from the same population. Right, so far I'm just copying. We were to select many random samples of the same size from the same population and construct and it says C%. What is my confidence level for this interval? 95. Construct a 95% confidence interval. I'm going to write that as CI. Using each sample. Comma. And then we keep copying. We expect about and then what goes in that next blank? 95%, good. 95% of the intervals And then I continue copying would capture the. And the big question, what population parameter am I estimating with this interval? Very good, mean systolic blood pressure, yeah. So would capture the true mean systolic blood pressure. And if you wanted to get bonus points with the AP readers, you would be very specific about the population you're referring to. For all US residents 8 years and older. Yeah? My recommendation for you, because we're going to see those 2 sentence frames over and over again all the way up until May. Keep this set of notes somewhere you can use it for every homework assignment for all of semester 2. Yeah, we're going to see those boxes again. All right, on the way out the door, I want you to show me your thumbs. How do you feel about today's notes? Thumbs up, thumbs sideways, thumbs down. Good morning. Give me your thumbs. Good. Sideways. Sideways. Thumbs up. Good. Thumbs up. Good. Have a good day, Gabe. Stacia. Stacia. Would you do me a favor and press stop on the recording? Thank you.